Lesson 3.4, Measures of Position. We will be able to determine and interpret z-scores, percentiles, quartiles, interquartile range, and check for data for outliers after this lesson. So what does a z-score measure? It is the number of standard deviations an observation is above or below the mean. How do you find a z-score? So for a population, the z-score is equal to the data value, so x minus mu, which is your mean, divided by sigma, which is your standard deviation. For a sample, your z-score is, again, your data value minus x bar over s. And for z-scores, we're going to round to the 100th spot. So again, a z-score is the standard deviation an observation is above or below the mean. So what would a positive z-score indicate? That means that the data value is larger than the mean. Then a negative means the data value is smaller than the mean. Let's look at an example. Determine whether the Boston Red Sox or the Colorado Rockies had a relatively better run-producing season. The Red Sox scored 878 runs in play in the American League, where the mean number of runs scored was mu equals 731.3, and the standard deviation was sigma equals 54.9 runs. The Rockies scored 845 runs and play in the National League, where the mean number of runs scored was mu equals 718.3, and the standard deviation was sigma equals 61.7 runs. So let's first look at the Red Sox. We want to find the z-score, because when we convert to z-score, we have numbers that are easy to compare. I'm going to underline the numbers that correspond with the Red Sox. So we have our mu and standard deviation. So this 878 is our x. That is the data value. So we take 878 minus the mean, all divided by the standard deviation. When you get that, you get 2.67. Let's do the same for the Rockies. So I'm going to underline again the information for the Rockies. So the z-score is going to be 845 minus 718.3, because that's the mean, divided by the standard deviation. You get 2.05. So who did relatively better? So in other words, who is farther from the mean? That would be the Red Sox. So the Red Sox had a relatively better year at scoring runs than the Rockies. With negative z-scores, we need to be careful when deciding the better outcome. For example, suppose Bob and Mary ran a marathon. Bob finished the marathon in 213 minutes, where the mean finishing time among all men was 241 minutes, and a standard deviation of 57 minutes. Mary finished the marathon in 239 minutes, where the mean was 273, and the standard deviation was 52 for the woman. Who did better in the race? So let's figure out the z-scores. Bob is going to be 213 minus the mean of 241 divided by 57. This is negative 0.49. And then Mary, which is negative 0.65. So Mary actually did relatively better. Even though Bob's z-score is larger, Mary did better because her time is more standard deviations below the mean. So when we are asked who did better, we're looking at who is the farthest from the mean.